Evaluation of mobile charging connectors. Here, let's start with introduction. When mobile phones were first introduced, there was no universal charging standard. Every manufacturer designed its own charger and charging port according to the phone size, battery technology, and internal hardware. This meant that a charger from one brand usually could not be used with another brand's phone. As smartphones evolved, batteries became larger, charging speeds increased, and users demanded a single charger that could work across multiple devices. This need drove the evolution from proprietary connectors to today's USB Type C and wireless charging technologies. In previous, let's start with the proprietary connectors. It came from 1919s to 2006. Mini USB in 2001 to 2008 it came. Micro USB it came 2007 to 14. Lightning connectors 2012. USB Type C at present 2014. Wireless charging 2015 present. Here let's start with proprietary connectors. Here, proprietary connectors in 1990 to 2006. During this period, 1990 and early 2000s, almost every mobile phone manufacturer uses its own proprietary charging connectors. Companies such as Nokia, Motorola, Sony, Ericsson, Samsung, Siemens, LG, and Panasonic all designed different charging ports for their phones. Since there was no industry wide standard, manufacturers focused on creating connectors that suited their own phone designs and necessary ecosystem. Here, for example, Nokia used several different connectors over the years, including the large barrel charger, the smaller 2 mm larger, and the pop port connector. Sony Ericsson introduced the fast port connector, which combined charging, data transfer, and audio functions into a single interface. Samsung and Motorola also developed unique multi-pin connectors that supported charging and communication with computers. These connectors carried basic electrical signals such as power VCC, ground GND, and data, while some also include pins for audio, external accessories, or device identification. The number of pins varied significantly, ranging from as few as 2 pins to over 20, depending on the manufacturer's design. Although proprietary connectors allowed manufacturers to optimize the connectors for their specific devices, they created major inconveniences for customers. Each phone required a different charger, making it difficult to share chargers between devices. If a charger was lost or damaged, users often had to purchase an expensive replacement specifically designed for their phone model. This lack of compatibility also contributed to significant electronic waste as people accumulated unused chargers whenever they upgrade their phones. As mobile phone adoption grew worldwide, consumers and governments began demanding a universal charging solution that would reduce waste and simplify charging across different brands. After that, mini USB it came 2001 to 8. Here, mini USB was introduced around 2001 as part of the USB standard developed for portable electronic devices. It was significantly smaller than the full size USB connector used to computers while still providing both charging and data transfer capabilities. Mini USB featured 5 pins, V bus for power, D plus and D minus for USB data communication, and ID pin used for USB on the GO, and ground for the return path. The connector became widely used in digital cameras, MP3 players, GPS devices, external hard drives, and some early smartphones. Compared to proprietary connectors, mini USB offered major advantages. It enabled manufacturers to use a standardized connector that worked across many different types of devices, reducing manufacturing costs and improving compatibility. Users could often use the same cable for different gadgets and making chargers and data transfers much more convenient. However, mini USB still had several limitations. Its physical size was relatively large for increasingly slim mobile phones, and it could be only inserted in one orientation, meaning users had to carefully align the connector before plugging it in. Repeated insertion and removal could also wear out the connector over the time. As smartphones continued to become thinner and more compact, manufacturers recognized the need for an even smaller and more durable connectors, leading to the development of micro USB. Micro USB was officially introduced in 2007 and quickly became the standard charging connector for Android smartphones and many other portable devices. In 2009, several major mobile manufacturers agreed to adopt micro USB as a common charging standard, and by around 2010, it had become the default charging connector for most Android phones. Micro USB retained the same 5 electrical pins as mini USB but introduced a much smaller and thinner connector that better suited modern smartphones designs. The connector supported both charging and USB 2.4 data transfer while also enabling USB OTG functionality through its ID pin. One of micro USB's biggest advantage was its universal compatibility. Consumers no longer needed different chargers for every Android phone, making charging simpler and reducing electronic waste. The connector was also designed to withstand approximately 10,000 insertion cycles, making it more durable than many earlier connectors. As smartphones batteries grow larger, manufacturers began introducing fast charging technologies such as Qualcomm Quick Charge, Samsung Adaptive Fast Charging, and MediaTek Pump Express. All through these technologies improved charging speed. The physical limitation of the micro USB connector restricted how much power and data it could safely support. Another major drawback was the micro USB was not reversible. Users frequently struggled to insert the connector correctly, and repeated incorrect insertion sometimes damaged the charging ports. The demand for faster charging, higher data transfer speeds, and a reversible connector eventually led to the development of USB Type C Lightning connectors. In 2012, Apple introduced the Lightning connector alongside the iPhone 5, replacing the larger 30-pin dock connector that had been used on earliest iPhones, iPods, and iPads. Here, the Lightning connector features the 8 pins and introduced a reversible design, allowing user to insert the cable in either orientation. Unlike previous connectors, Lightning and used intelligent circuitry dynamically assign signal functions depending on how the connector was inserted. Lightning offered several improvements over Apple's older, older connector. It was significantly smaller, more durable, easier to use, and supported both charging and high speed data transfer. Because of its compact size, Apple was able to design thinner smartphones with more internal space available for larger batteries and additional components. Despite these advantages, Lightning remained a proprietary Apple technology. Users needed Apple certified cables and accessories which were often more expensive than standard USB cables. As USB Type C matured and became the global standard for charging, data transfer, and power delivery, Lightning gradually became less competitive. Apple eventually transitioned many of its products to USB Type C, allowing better compatibility with chargers used by Android phones, laptops, tablets, and other electronic devices. USB Type C was introduced in 2014 by the USB Implementers Forum to create a single universal connector cable of supporting charging, data transfer, video output, and numerous other functions. Unlike micro USB, USB Type C contains 24 electrical pins that enable much higher power delivery and significantly faster data communication. Important charging related pins include VBus for power, ground for ground, and configuration channels CC1 and CC2, which allows devices to negotiate charging voltage, current, and cable capabilities automatically. One of the USB Type C most popular features is its fully reversible design, eliminating the frustration of inserting the connectors in the wrong direction. Is also support USB power delivery, enabling the devices to negotiate different voltage and current levels based on their power requirements. Modern USB C chargers can safely charge smartphones, large tablet, laptops, gaming consoles, monitors, camera, and many other electronic devices using the same connector. Depending on the specification, USB C supports power delivery up to 240 watts, allowing even high performance laptops to charge through the same connector USB by mobile phones. USB Type C also supports advanced technologies such as port, alternate mode, Thunderbolt, HDMI output, PCI Express communication, and high speed USB 4 data transfer. The versatility has made it universal connector for modern electronics. Wireless charging became increasingly popular around 2015 with the adoption of Q wireless charging and standard by major smartphones manufacturers. Unlike wide charging, wireless charging eliminates physical charging pins entirely. Instead, electrical energy is transferred using electromagnetic induction between a transmitting coil inside the charging pad and a receiving coil inside the smartphone. When the phone is placed on the charging pad, alternating current flowing through the transmitter coil generates a magnetic field. The magnetic field induces an electrical current in the receiver coil inside the phone. When the phone is placed on the charging field, alternating current field flowing through the transmitter coil generates a magnetic field. The magnetic field induces an electrical current in the receiver coil inside the phone, which is then converted into DC power to charge the battery. Wireless charging offers excellent convenience because users simply place the phone on a charging pad without connecting a cable. It also eliminates wear and tear on charging ports and reduces the chance of connector damage. However, the wireless charging is generally less efficient than wired charging. Some energy is lost as heat during the transmission, making charging slower and causing the device to become warmer. Accurate alignment between the phone and charging pad is also important for efficient power transfer. All through magnetic alignment systems such as MagSafe have improved the experience. Here, the conclusion is the evaluation of mobile charging reflects the industry's constant effort to improve convenience, performance, and compatibility. We moved from a time when every manufacturer uses its own priority charger to standardized USB connector and finally to the highly versatile USB Type C, which can charge everything from smartphones to laptops. At the same time, wireless charging continues to evolve, offering a cable free experience. The future is likely to bring even faster charging, more efficient wireless power transfer, and a truly universal charging ecosystem where one charger can power nearly all of our electronic devices.